Lesson 1-7. For our summary slide, you can write an answer to the question, what did we learn yesterday? Or what did we learn in our previous lesson? Our learning target is I can determine if a relation is a function. Our essential question is how do you determine if a relation is a function? We have 3 vocab words today. The first one is function. What a function is a special relationship where every input value leads to exactly one output. So every input value leads to one output. So when you substitute something for x, plugging something in for x gives you only one answer for y. Next, we've got the vertical line test. This is a test to use on graphs to see if they're a function. And I'll talk about that more on our example slides. And then the last one is function notation. Function notation is this. This is an example, like f of x equals. So how I just read that was, I said f of x. Like that's how you read it. F of x. And we are going to be working with some equations where instead of saying y equals for our equation, y equals 3x plus 1, it will be f of x equals 3x plus 1. Those two equations are the same. They're the same. It's just a different notation. And I would say the importance of the notation is just because it's like saying to recognize that this is a function in terms of x. Like x is your independent variable. So a function f of x means it's a function in terms of x being your input variable. Okay, are these functions? Now I'm going to teach you that vertical line test. Vertical lines are straight up and down. So these are vertical lines, okay? So the vertical line test says that if you draw vertical lines through your graph, and each vertical line, so one vertical line, touches your graph one time at the most, then it's a function. So you draw vertical lines, so the vertical line test, draw vertical lines through your graph. So this is kind of like the steps. So draw vertical lines. Does each one, you ask yourself, does each one touch the graph once? At most. Because it doesn't have to touch the graph at all. But if each one touches the graph once, at the most, then it's a function. So yes, function. No, not a function. Okay, so now I'm going to demonstrate this on my graphs on the left. Vertical lines. Touches once, touches once, touches once. I could keep on going. Each one touches once. So yes, this passes the vertical line test. And then my second one touches once, but over here touches twice. No, fails the vertical line test. So draw vertical lines through the graph. Every vertical line has to touch at most once. So either it doesn't touch at all or it touches once to be a function. next to. Same thing. Draw your vertical lines, touches once, once, once. These are all once. So yes, passes the vertical line test. And then the bottom one, over here it looks good. Yes, 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 yes. But right here where the blue line actually is no. It touches everywhere. It touches like an infinite number of times on that vertical line. Okay, so that's graphing. Now we're going to move on to a different representation. If you want to, you can draw graphs for these. I don't want to draw a graph though, so I want to think about that one-to-one relationship. So each value in the domain has to give me one value in the range. So I look at these values in the domain. They're each giving me a different number over here. And as long as these domain values are different, it's a function. So each of those leads to its own output value. So I am going to say yes. The domain values don't repeat. Or the domain values are all different. So each, you could also say like each input gives one output. Each domain value gives you one output. Now look at this next table and notice these threes that are repeating. So we're good with the 1 and we're good with the 2, but because the input 3 is going to 2 outputs. So you think about like on a graph, what that would look like. 3, 2 is up here, and then 3, -1 is down here. So you can see that they're on the same vertical line. So I'm going to say no, because x repeats the 3. So it's the domain or the x value that you have to focus on, because if that value repeats in your table, that means that that input 3 is giving you 2 different outputs. So the input 3 gave you 2 outputs, and it's only allowed to give you 1 to be a function. On a mapping, it's very similar. So on a mapping, each of these numbers is different, and they've each got 1 ray. So this is a function. So I'm going to say yes. Each output, to give you a different idea, each output leads to 1, or sorry, I just said that wrong. Each input, oh my gosh, each input leads to 1 output. I'm just trying to give you some different ways that you could explain. And then on the bottom one, right here, I want you to notice that -3. So this one is not a function. No, -3 leads to both 1 and 4. So that input of -3 has 2 output values. So it's not a function. You can always draw graphs, and then the vertical line test can be your reason. I just hope that you don't have to spend that much time. So let's focus on our input values. These are all different. So I'm going to say, yes, this is a function. Input are all different. But then the bottom one, look at the inputs. So this one's going to be no. X repeats -2. So that -2 input has 2 different outputs, 6 and -1. Okay, now we're switching over to function notation, and I'm going to teach you how to evaluate functions. So we've got 2 different function rules. So you've got to make sure that you're looking at the correct function. I'm going to write both of the function rules here, and then I'll explain what I mean. So this first problem says evaluate f of 5. So that means the function that starts with f, so that's this one. So we're going to evaluate f of 5. And I'm actually going to switch colors here to kind of hopefully have this make sense. So when they say evaluate f of 5, what I want you to notice is that it used to say f of x, now it says f of 5. So what that means is that they want you to plug in 5 for x. Plug in 5 for x. So on the other side where the x is, you're also going to plug in a 5 right there. And then you can solve. So using the order of operations, I have to do my exponent. So 5 squared is 25. And then 3 times 25 is 75. So that's how you would evaluate it. Now the next problem says g of -2. So I've got to move over here and use this rule. So I'm plugging in -2. So I have to turn my x's into -2. So see this x here, -2, and this x over here, also -2. Then I use PEMDAS. 4 times -2 is -8, minus 5, -13, like that. And then the last two, I've got f of -1. So I'm just going to go over here, and I'm turning x into -1 this time. So both of my x's turn into -1s. -1 squared is 1. 3 times 1 is 3. And then g, and then what they're substituting this time is h minus 1. So this one's a little bit trickier. So it's like this. Okay, so look at where the h minus 1 was. So again, in the rule, like I'm looking way up here, in the rule g of x equals 4x minus 5, I replaced both of the x's with h minus 1. So this one's not going to look quite as nice when we simplify it. We distribute 4 times h is 4h, minus 4 times 1 is 4, and I bring down my -5, and you're not going to get a nice number for an answer here. You can combine the like terms though, -4 and -5, to get -9. So the first three, we got nice numbers, 75, -13, and 3. But then on this one, we still have a variable, 4h minus 9, because we were replacing the variable with a different variable, h minus 1. So substituting to replace the x with whatever is inside the parentheses here. So replacing x with whatever's in these parentheses. Replacing x. And then simplifying. And when you replace the x, you're replacing it on both sides.